Our next move is to talk about maximization in a situation where you have spreadsheets. Now notice the difference here. We don't have continuous functions anymore. We've got a quantity that goes from 1 to 2 to 3 to 4 to 5. There is no 1.5, there is no 2.5. Because notice we're producing jet airplanes. And so the optimal number of jets is not going to be 1.5 jets because the half a jet is just not going to do the job for what you want to do. People have tried flying half jets, but I don't think that works very well. Now, notice I've given you, this is the kind of information you often receive. This is the average revenue for production, and this is the average cost that you're getting in these situations. Averages are relatively easy to calculate, and that's usually what you're given. But that's not the same thing as a marginal. So let's drop down and define average revenue and average cost and compare that to the definitions of marginal and average. So average revenue is equal to total revenue divided by quantity. That's the definition. So it's relatively straightforward. It's like the mean revenue if you're doing statistics. It's the average revenue. What is the definition of marginal revenue? Take a moment and write down what you think that definition is. Now that you've written down the definition, marginal revenue is equal to the change in total revenue divided by the change in quantity. Is that the same thing? Well, notice this is a total revenue amount divided by a quantity. This is level of revenue and a level of quantity. This is the change in total revenue divided by the change in quantity. And so this is a major difference between these two. So when you're thinking about maximization before you start doing these things, you should work that out. All right, so I want you to take a moment and look at this problem. Here it is. Here are the average revenues and average costs of production of jets in millions of dollars. Now, occasionally I've had people complain when I've taught the class that the numbers we use are too small. They're just not meaningful. I don't care about ones and twos and things. So anytime you see a number you think is too small, you just multiply the whole problem by a million or a billion, and then you can decide it's a much bigger number. So the question we want to ask is, if we want to maximize profits, if we're shooting to maximize total profits, what is the optimal number of jets to produce in that situation? Our goal is to maximize total profits. What's the optimal number of jets to produce? Take a moment, and you should try to solve it. I actually put it over here in a spreadsheet type situation as well. Same exact numbers. This is average revenue. This is quantity. This is average cost. So think your way through what you would do to figure out what the optimal point is to maximize total profits. I'm presuming that you've solved the problem now. You should have solved the problem. If you haven't worked your way through it, then you're cheating on this. You need to be working your way through these problems. That's the only way you'll understand what's going on. And I'm going to repeat this to you over and over again, so you might as well just get used to it. So here are some suggestions that people have had in the past. I've had people suggest that we should stop at 6. And the argument is that, well, we're going to have, what we want to do is we want to set average revenue equal average cost. But was that the rule that I told you from the previous time that we talked about the calculus? Well, the rule before was to set marginal revenue equal to marginal cost, right? And remember that marginal revenue is not the same thing as average revenue at all. Now, notice one thing about this is that if this is your average revenue and average cost, how much money have you actually made? Well, you've made 0. I think you can do better than that. What is the optimum? Well, let's go through and solve it. The easiest way to solve this problem is to calculate the total revenue. And how do I get the total revenue? Well, the total revenue is just equal to average revenue multiplied by quantity, right? All we're doing is we're going to multiply Q and divide it by Q, and that takes it out of this side. We multiply by Q over here, and you're going to get that total revenue is equal to average revenue times Q. So let's find total revenue. Well, total revenue is going to be equal to, let's get the general formula, it's going to be equal to average revenue in B3, which is 10 in this case. And what are we going to multiply that? We're going to multiply by the quantity of 1, which is in A3 in this case. And we're going to get a number of 10 for that, right? Well, what's average revenue for number 2? Well, it's going to be equal to the quantity 2 times the average revenue of 9.5, so it's going to be A4 times B4 in general. So we get 19 in that case. And if you do the rest of the Excel, so it's going to be 3 times 9. And we can just bring this thing down. And so it's going to equal 27, which was A5, which was 3, times B5, which is 9. All right? So let's bring that down. And so our total revenue here are these numbers. You should take a moment and you should if you haven't already done so, you should calculate total cost. Here's your total cost function. And this is going to equal average cost, which is C3 in this case, which is equal to 5, times quantity, which is equal to 1, which is A3 in this situation. And this is going to be equal to, if you look at 2, it's going to equal 2, which is A4, multiplied by average cost, which is 5.5, which is also the same thing as C4. You get this. Let's do it one more time. So we're going to multiply the quantity of 3, which is A5, times 6, which is average cost, and we get 18, and we just keep bringing it down. The next move then is to calculate total profit, and we just take total revenue minus total cost. So we're going to take 10 in D3, and we're going to subtract 5 in E3. We're going to go through and we're going to take 19 in D4, which is total revenue for 2. Right? This is the 2 line. And we're going to subtract total cost in E4, which is equal to 11. So we took 19, subtracted 11, and got 8. We take 27 and subtract 18, and we're going to get 9. So that's going to be equal to 27, which is D5, minus 18, which is E5. We have the general rules there. We come all the way down. So notice the situation you're in. The maximum profit in this case is the point where you get the largest total revenue minus total cost equal to total profit. So that's the easiest way to solve it. If you get to see the whole picture this way, it's going to be very nice. So this is the largest profit you can get. Notice that if you went to the point where average revenue was equal to average cost, you're going to make 0 profits. And notice also that you're going to make more money here at 3 than you're going to make at 5 when you have only 1. Now in the spreadsheet situation, I also want to show it to you in terms of marginal revenue and marginal cost, because that's really important. Remember, we were talking about maximization before. We were trying to find the largest total profit. And the optimal way to do that is to find the point where marginal revenue is equal to marginal cost. Now remember, that was in a continuous function relationship. We showed in the math section of the course that the continuous relationships don't exactly give you the same situation as when you have a spreadsheet and you're going from 0 to 1 to 2 to 3 to 4. I want you to remember the definition of marginal revenue. It's equal to the change in total revenue divided by the change in quantity. And I want you to take a look at the spreadsheet. And I want you to take a moment, and I want you to take this total revenue section, and I want you to calculate marginal revenue. Now that you've done that, let's try it out. Now, the definition of marginal revenue, again, it's the change in total revenue divided by the change in quantity. In this case, we should have added a 0 here, so I apologize for that. So this is 0, this is 0, this is 0, 0, 0, 0. All right, so what we're going to do is we're going to go from 0 to 1 on the quantity. That's going to cause total revenue to go from 0 to 10, right? So marginal revenue for the first unit is going to be equal to, put this in parentheses, the change in total revenue. And the change in total revenue is going to be 10, which is D4, minus 0, which is D3. Okay? And we want to divide that by the change in quantity. And the change in quantity here is going to be 1, which is in A4, minus 0, which is in 3. We divide that through. Now every one of these is, what's the change going to be as we go from 1 to 2 to 3 to 4 to 5 to 6 to 7? Well, it's always going to be 1. But that's not always the case when you're looking at these kind of spreadsheet situations. So you need to be aware of that when you're thinking about marginal revenue. Remember, it is the change in total revenue divided by the change in quantity. All right, so let's redo this again. Marginal revenue for the second unit is going to be D5 minus 10, which is D4. And then we're going to divide by 1, which is the change in quantity. And we're going to get 9, right? So if you haven't already done so, I want you to finish out the rest of the marginal revenue curve. All right, so this is going to be equal to the change in total revenue, which is D6, which is 27, minus 19, which is D5, and we're going to divide that by 1, so it's going to be 8. If I want to find the situation for the marginal revenue for 4, that's going to be 34 minus 27, right? So that's going to be equal to 34, which is D7, minus 27, which is D6, and we're going to get 7. This one's going to be equal to 40, which is D8, minus 34, which is D7. So you can see every one of these, we're looking at the change in the total revenue, the change. That's what this marginal revenue is. And we're dividing by the change in quantity. And the only reason I'm not putting it all in there with the change in quantity is the change in quantity is always 1 here. So let's finish it out that way. All right, so next step is I want you to calculate marginal cost. Now that you've done it, how do we calculate marginal cost? Well, it is equal to the change in total cost. So we need to go, we're going to go from 0 to 1, 0 to 1. So to get the marginal cost, it's the change in total cost. So we go from 0 to 1 here, and it's going to be equal to 5, which is E4, minus 0, which is E3. All right, and then we're going to divide by the change in quantity again. And what's the change in quantity? Well, we're going from 1 back to 0, right? And which is going to be from A4 back to A3. So that's the overall formula. If you go through and do this, what you're going to get is these numbers come back down, right? So what is this number? Well, look at it. It is 11 minus 5 divided by 2 minus 1. And so that's going to be 11 minus 5 is equal to 6. 2 minus 1 is equal to 1. And 6 divided by 1 is equal to 1. So remember that the marginal cost is the change in total cost, divided by the change in quantity. So that's where these numbers come from. The example I gave you is one of jet airplanes. But a lot of times you don't get to see the information all in front of you in a spreadsheet the whole way through. A lot of times what happens is you see it piece by piece. So for example, say you're making movies. Think about all those various movies that have all these various sequels to them. You know, Lethal Weapon or Saw or Halloween, all those gory movies where we seem to have 25 sequels, right? So here's the marginal revenue that you expect. So the first sequel, say we're talking about Lethal Weapon 1. Well, Lethal Weapon 1 is the marginal revenue is 10, the marginal cost is 5. That was the cost of the first movie. So did they make money? Well, the marginal profit, right, is going to be equal to this 10 minus this 5. So it's going to be equal to 10, which is G4, minus 5, which is H4. So they made $5 million. Should they produce it? Well, yeah, they're making $5 million. Let's look at the next one. Well, their marginal revenue is 9. Their marginal cost was 6. Marginal revenue typically falls because the sequel never does as well. The marginal cost typically goes up because if they do well in the first round, then people become stars. You have to pay them more. So in this case, it's 9 minus 6. So end up with marginal profit equal to 3. Are they making money? Yeah, they're making money. They made money on the second movie. So what about the third movie? Well, the value is going to be equal to, marginal revenue is going to be 8. Going to subtract off the marginal cost. Did they make money on the third movie? They sure did. They made $1 million. So should they make the first 3 movies? Well, yes, because they've just increased their profit, right? Now, what about the fourth movie? By this time, you know, the marginal revenue is dropping, the stars are more costly, and so that's going up. And so in this case, you're going to make $7 million in revenue, and you're going to subtract off $8 million in costs, and you're going to lose $1 million. Should you make that movie? Not unless you expect that you're going to make money on the next ones. And typically what happens is, you can see if we just go through the rest of this, what's going to happen to these guys. Well, at 5, they made $6 million, but they in revenue, but then they spent $9 million in costs, so they lost $3 million. This is looking more and more like a loser, and this is a common situation that pops up. Now, did we get the same answer as before? Well, remember, our first answer, the optimum was 3, right? And total profit was equal to 9. So we picked this 3 over here because this 9 was the biggest number of all the total profits, right? Now, did we make the same choice here? Well, in this case, what we did was we compared marginal revenue and marginal cost. So we compared marginal revenue and marginal cost for each movie, and we decided to make the first 3 movies. So does that make sense? So we got exactly the same answer. Now, was marginal revenue actually equal to marginal cost in this case? Well, it turns out no, because we're not looking at continuous functions. So what we did is we avoided going to 4. We avoided trying to go to the point where we lost some money. So we found the solution to the overall problem. Thus, what we need to do now is let's look at the general rules in situations where you're choosing quantity that maximizes profits in a case where you choose among integers. So we're looking at situations where we're going from 0 to 1 to 2 to 3. We're not going from 2.99999 to 3 or 3 to 3.0001. We're choosing between 2 and 3 and 4. You can't have a half movie, you can't have a half airplane, that kind of situation. Well, we're going to keep producing as long as marginal revenue is greater than or equal to marginal cost. So notice it's down to marginal revenue and marginal cost again. And then what we want to do is we want to stop producing and avoid situations where marginal revenue is less than marginal cost. Now, in general, there are going to be situations where you might lose money on the first few, but then you're going to make enough money on marginal revenue and marginal cost after that that you're going to do fine. All right, so which brings us to this next point. You also need to check to make sure that the total profit at the quantity you choose is greater than, so it's greater than the total profit at 0. That's the key thing that you're looking at there. So you want to choose quantity using marginal revenue and marginal cost, and then you want to check to make sure that your total profit at the quantity that you choose is greater than the total profit at 0. All right, in other words, that the revenue covers all relevant costs. Well, notice, so marginal revenue is greater than marginal cost here. We made $5 million. Make the first movie. It was greater, marginal revenue of 9 was greater than marginal cost of 6 here. We made $3 million. Make that movie. Marginal revenue was greater than marginal cost here. They made $1 million. Make that movie. Should you make movie number 4? Your revenue was 7. Your cost was 8. You lost $1 million. Don't make that. Okay? Now, notice that if I add up 5 and 3 and 1, what do I get? I get 9, and that's my total profit. All right, so in that case, did I make more money than at 0? Well, here was 9. Here was 0. I made more money at 0, so this was the right move to make. General rule, keep going as long as marginal revenue is greater than marginal cost, and then check to make sure the total profit at that quantity is greater than the total profit at 0. Our next move then is to work our way through the maximization issues using graphical techniques with marginal revenue and marginal cost.